Welcome to this lesson on solving systems of equations using substitution. So far you've learned how to use graphing as a way to find your solution to systems of equations. Today we're going to teach you another strategy or tool to use in order to solve the system of equation. That strategy or tool is the method of substitution. On your screen are the steps for using substitution to solve a system of equations. Step 1, if needed, isolate one variable. That means get x by itself, get y by itself, whatever the given variables are, select one of them and isolate them to get a value for that variable. Step 2, substitute that value of the variable into the other equation. Step 3, once you've done the substitution, solve the equation to find the value of the other variable. Step 4, if needed, use that answer to substitute into the other equation to find the value of the other variable. Your final step 5 is to remember that your solution for a system of equations is always written in an ordered pair. Remember that you should be using a comma to separate your two values, and your ordered pair should be surrounded by parentheses. Now let's use our steps in order to solve several examples. Step 1, if needed, isolate one variable. X has already been isolated for us with a value of 4, so step 1 has really been done for us in this situation. Step 2 was to substitute the value of the variable into the other equation. So I'm going to take the value of 4, which is what x is equal to, and substitute it into this equation. So I'm going to substitute 4 in place of the x. Step 3 is to solve the equation. So I'm going to go ahead and do my mathematical calculations and solve for the value of y. Step 4, if needed, use that answer to substitute into the other equation to find the other variable. In this situation, I have x already solved for and found, and I have my y value. So once I have a value for each variable, I really have what I need in order to write my solution. So now I can go on to step 5, which is to write my solution as an ordered pair. So I'll write my x value, my y value, separated by a comma and surrounded by parentheses. So had I used the strategy of graphing, this point of 431 is where those two lines would have intersected on the graph. Let's use our steps to solve this next example. If needed, I should isolate one variable to get a value. As you can see, x has already been isolated for me and has a value of -3. So I'm going to take that value of -3 and I'm going to substitute it in to the other equation. So I will substitute in -3 for x. In algebra, when we have a numerical value written right next to a variable, it means multiply. So I'm going to multiply 6 times -3, which is -18. And I'm now going to use my knowledge of solving equations and using inverse operations in order to find the value of y. I'm going to add my opposite for integers and then divide by 3 to find that the value of y is 11. Now that I have a value for my x variable and for my y variable, I have what I need for my solution. I'll write my solution as an ordered pair, the comma separating it and surrounded by parentheses. Here's our next example, and you can see that the variables are different. They're no longer x and y. It doesn't matter which variables are used, your steps are exactly the same. So I have one variable that's already been isolated for me, so I'm going to use that value and substitute it into the other equation. Do my mathematical calculations, and again I will use my knowledge of inverse operations and solving equations in order to solve for the other value. I will take that value and write my solution as an ordered pair. How do I know which order to write my values for my ordered pair? You write the ordered pair solution in alphabetical order. So in the last example, the variables b and a were given. So my ordered pair solution will be written in the order of a, then b. Another example, if the variables q and m were given, then I will write that solution in alphabetical order. So the value of m will go first, followed by the value of q. Here's our final example. Step 1 is, if needed, isolate one variable. This has been done for me because I have the variable of f all by itself in this equation, f equals 3d. I'm going to use that value of f and I'm going to substitute it in to this other equation. So I have d plus f is equal to 3d equals 8. I have like terms on the same side of this equation, so I'm going to go ahead and combine those. If I have 1d and I add 3 more d's, I now have 4d. And I'm going to use my knowledge of inverse operations in order to find the value of d, which is 2. So we just completed steps 1 through 3. Now step 4 stated that you might have to substitute this value back into the other equation so that I can have one final numerical value for f. So I need to write down that equation, substitute 2 in for d, since that's what I just solved for, in order to get the final numerical value of 6 for f. I now have a numerical value for my variable d, and I have a numerical value for my variable f. I can take that information and write the solution for my system. And again, my solution is going to be written as an ordered pair, and since I have the variables d and f, I need to write the solution in alphabetical order. So d comes before f in the alphabet, so my value for d will come before my value of f.